All right, so our first example here is again the easiest one, where we're told the material. Okay, if we know the material, then we can calculate molar mass, big M. All right, so for calcium we got 40.08, right? Okay, so we got 40.08 because there's only one calcium. Okay, we have one carbon in there, so that's going to be 12.01. Okay, and we've got 3 oxygens, so plus 16 times 3. Okay, so when we do that, okay, so we got 40.08, okay, plus 12.01 plus 48, which is 16 times 3. Okay, so we got 100.09 as our molar mass here, grams per mole. All right. The other thing they told us is little m, the mass in grams of this material, 125 grams. They're asking us how many moles, so we're looking for n. Okay, we don't have to manipulate the mole equation to solve for n. It is already set up for that, so we just have to plug in our numbers. 125 grams divided by 100.09 grams per mole, okay, and that'll give us about 1.25 probably. Yeah, 1.25 moles. Okay, and remember always your answer must have units on it so that it is right. Okay, so you'd get a mark for molar mass, mark for your calculating, a mark for your answer. That's a 3-mark one. Okay, how many people have done number 2? All right, let's have a look at 2 then as well. Okay, so for number 2, we're looking at what's the mass of 2.7 moles. All right, so they told us N this time, 2.7 moles, okay, of lithium phosphide. So we can calculate big M, right? Lithium is 6.94, okay, and phosphorus is 30.08. What have I done wrong, guys? Oh, sorry, is it 30.97? Sorry, what else have I done wrong? Right, I didn't multiply this by 3. There are 3 lithiums. Okay, good. 3 times 6.94 plus 30.97. Okay, so we got 51.79 grams per mole on that stuff. Okay, I want to calculate little m. So mole equation is set up like this. I want little m, so I got to multiply both sides by big M, because if I want to move something, I do the opposite. And then what I do to one side, I do to the other. Okay, and I've got m times n equals little m. So when I plug in my numbers, that's going to be 51.79 multiplied by 2.7 moles. Okay, so times 2.7, 139.83. What are my units for that? Just grams, right? Okay, I'm only going to have grams per mole if I'm talking about molar mass, the mass of 1 mole. Okay, so when I calculate big M, that is the mass of 1 mole, which is why it's grams per mole. Okay, if I'm just finding mass, it's just grams. All right, how many people have done 3? All right, I'll give you a little bit more time on 3 then. What's the extra step in number 3? Right, you got to use Avogadro's number, and in this case you use it by multiplying the number of moles by it to get the number of molecules. All right, so we've got iron 3 oxide, okay, as our material. Okay, so we're going to have, what is that, 55.85? Yeah, 55.85 times 2, because there are 2 of them, and add that to 16 times 3. Okay, so 55.85 times 2. Come on, turn on. 55.85 times 2 plus 48. Okay, it's 159.7 grams per mole. All right, and they told us the mass, 230 grams. If I'm going to find the number of molecules, I first have to know how many moles. Okay, because to find the number of molecules, I use Avogadro's number, the number of molecules in a mole, by multiplying it by the number of moles. Okay, so number of moles then is going to be little m over big M. So that'll be 230 divided by 159.7. What is it? 8.67. All right, so we got 8.67 moles. Oh, sorry. I was going to say, that seemed kind of big. Sorry. 1.4 what? 4. Okay. Moles. All right, so we got 1.44 moles. Now I'm going to take N and I'm going to multiply it by Av's number, okay, to get the number of molecules. Okay, so that's going to be 1.44 times 6.02 times 10 to the 23. So remember when we punch that into our calculator, okay, we go 1.44, and we multiply that, then we put Avogadro's number in brackets. Okay. All right, so we get 8.67 times 10 to the 23. And our units are molecules. Now, something I see sometimes, okay, on tests and quizzes is that people just write this number. Is that the same as 8.67 times 10 to the 23? No, it's about 10 to the 23 times smaller. Okay, not exactly the same number. Okay, so yeah, you got to make sure you keep that times 10 to the 23 on there, not just the base number. All right. Okay, questions on number 3? Okay, remember the Marks distribution is 1 for molar mass. Okay, you're going to have 1 here for calculating the number of moles. Okay, you're going to have 1 for correctly using Avogadro's number and 1 for your correct answer. Carly. How do you know like what to multiply by? Like how would you know how to divide? It would give you the number of molecules. Oh. Right? If you're going to divide by Avogadro's number, the question will be asking you to get mass. So you put in like, so say it's just like this, you just put 1.444 divided by that in brackets? No, it would be, you would have this number, the one you calculated, divided by 6.02 times 10 to the 23. That would give you the number of moles, right? Okay. So if you're trying to find, if the question gives you the number of molecules, you're probably going to have to find the number of moles to do anything with that number, right? And so really what we have here is that number of moles also equals number of molecules divided by Av's number. Okay? I mean, that formula manipulates exactly the same way that this one does. Right? There's 2 ways to calculate N. It just depends on what you're given. Yeah? All right, how many people have done number 4? How many people need a little more time? Okay. Okay, so a little point of clarification or a little tip for you for next week. Okay? A lot of people get confused as to when they should use Avogadro's number. Okay? When you read the question, all you have to look for is one word. Yeah. If you see this word in the question, you're going to have to use Avogadro's number. You're either going to be dividing by it or multiplying by it, but you know you're going to have to use it. Okay? If it doesn't mention molecules, it's just an N equals little m over big M problem. Okay? And you won't have to use Avogadro's number. Everybody follow me there? Because I sometimes see that on the unit exams. People are like, well, Avogadro's number is important. It must be involved in everything, and they use it when they're not supposed to. Okay? And then they get the wrong answer. It's only going to be used if you're given molecules or asked to find them. All right, so we are told the number of molecules. Okay? And it is 5.42 times 10 to the 21. Is that more or less than 1 mole? That is way less. Okay? This is about 100th of a mole. Okay? It's 2 factors of 10 smaller than a mole. All right. All right. So what else do we have? Well, we have the ability to calculate big M because we know that this is nickel 2 nitrate. All right. So for nickel, we got 58.69. Oh, sorry. Yeah, 58.69 for our nickel. Okay, so there's only one of it, right? We got how many nitrogens? 2. Okay, this 2 only applies to what's in brackets, right? So we got 14.01. times 2, okay? And then we got 3 oxygens times 2 is 6. All right, so we got 6 times 16. So we got 58.69 plus 28.02 plus 6 times 16. All right, so 182.71 is our molar mass. Okay, so we've got that. What can I find if I have number of molecules in Avogadro's number? Number of moles, okay? N is going to equal 5.42 times 10 to the 21 divided by 6.02 times 10 to the 23. So really what I'm doing here is kind of a calculation like this. Someone's asking me to figure out how many dozen eggs I have if I have 6 eggs. Okay? Do I have even a dozen eggs? No, but I have how many? 6, which is how much of a dozen? Half, right? So I'm taking this number, the number I have, dividing it by the number that represents it, okay? In this case, Avogadro's number, to figure out how many of that representative unit I have, in this case, moles, right? So when we do that, okay, we're going to have 5.42 to the 21 divided by Avogadro's number. All right, so we have, like I said, even less than 100th of a mole, just less than 100th. We have 9 1,000ths. Okay, or sorry, I said that wrong. I'm terrible with fractions. Okay, 900 1,000ths. Okay, of a mole here. Okay, so it's a small number. Okay, we'll write it down. N equals 0.009 moles. All right, so we need to now calculate our mass. I have N and I have big M. Okay, so we have N equals little m over big M. So I multiply both sides by big M. Okay, and now I'm set up for that. So little m will equal 182.71 multiplied by 0.009. All right, so we get 1.64 grams. Okay, that's a 5-mark question. 1 for the answer, okay, 1 for this calculation, 1 for the manipulation of the mole equation, 1 for the proper use of Avogadro's number, and 1 for your molar mass. Okay. Questions on that? All right.